Today we're going to start with our Intro to Probability unit and talk a little bit about permutations and combinations and what the difference are between those two. So I want to refresh your memory a little bit on just what is probability, and maybe before you drew some tree diagrams. It's probably been a while, but I know all of you did them in middle school. So maybe you had questions like they asked you how many different ways you can do something, and maybe you talked about flipping coins and you drew heads and tails. Or here we have they have a sporting goods store and they're talking about snowboards, and then you had all terrain, and then there's speed and carving boards, and then maybe this is just a basic tree diagram, A, S, C, and we're seeing how many different combinations. And then there's two types, soft boards and hard boards. So then the tree diagram would be soft boards and hard boards. And then we can count every possibility that we have, S and H, and then we'd go 1, 2, 3, 4, 5, 6. Oh, we have 6 possibilities. And you could do that for larger amounts too, and then just count how many we had and see that way. Or we can use the fundamental counting principle and say how many options did we have at first, which would be 3, and then how many options did we have the second time, the second possibility, and that would be 2. And another way to figure out this problem would be 3 times 2, which would be 6. And that's all this is saying. So if we have 2 events here, this m times n would be, we're multiplying them together. We are doing m ways, and another event would be n ways. And then if we multiply them together, that's how we figured out it would be 6. So the next would be how many different ways we can frame a picture. So we have 12 different styles. That would be our first way. And each style is available in 60 different colors. And then we want to use a blue mat board, and that's available in 6 or 8 variations. So times 8. And it wants to know how many different ways we can frame the picture. So we have 20 times 60 times 8. And then we have 5,760 different ways we can frame that picture. So a common way you see these sometimes is with outfits. They ask you how many different outfits can you have in your closet if you have different pants, different shirts, and you're not worried about matching or which goes with what, just how many different outfits, and you just multiply all the different combinations together. Those types of questions come up quite frequently. Okay, also common is license plates. So we have the standard license plate in Virginia. We have 3 letters. So I like to draw blanks. It helps keep myself organized. So we have 3 letters. And now we have followed by 3 numbers. So I'm just giving myself away to figure out what I have. And how many different license plates can I have? So now I want to think for my letters, how many different options do I have? And there's 26 letters in the alphabet. So I have 26 options for my first spot, and I can repeat them. There's nothing that says I can't. So I have 26 options for my second, and 26 options for my third. And now numbers, you want to be careful, because a lot of times I hear 9, but there's actually 10. Don't forget about 0. Because there's 1 through 9, but there's also 0 that could go there as well. So there's my options for numbers. So we multiply all these together. Please use a calculator. We'll be here a long time if we try to do this by hand. And we have 17,576,000 different license plates for this problem. So now we want to see how this changes if it cannot be repeated. So I'm going to do the same thing. I like drawing these blanks to keep myself organized, and it helps me visualize what I'm looking for. And for my letters, the only difference in this problem is now I can't repeat them. So I'm going to first start out with 26 letters in the alphabet, but if I can't repeat them for my second blank, now I have 25 to choose from. And now in my third blank, I have 24. And now for numbers, I'm starting with 10, and now I have 9, and now I have 8 because I've already used one. Here are my numbers. And we can see how that's going to affect our total number of different license plates available to us. And figure that out. I'm hoping you're pausing in between and figuring these out before you just see me try all of them. And we're having 11,232,000 different available license plates. Okay, now we're going to start talking about permutations. And with permutations, I can't stress this enough. Order matters. And I'm going to say that a lot. If the order matters in something, it's a permutation. And you're going to see what I mean by that more as I go through some of the examples. But the one that I think of the most is when you're in a race. It matters if you come in first or second or third, because if I change the order, it's a different situation. The second place person is a whole different situation than if they come in first. That's definitely a permutation. So anything involving a race and the order people come in, that's going to be a permutation because the order definitely matters. And there's other situations too. But the order matters, it's a permutation. Now, there's formulas for these, but we're going to use the buttons on your calculator. So please, please, please make sure you have your graphing calculator with you for these. The fundamental counting principle can also be used with the buttons for permutation, and we'll talk about that in a minute. It's also the arrangement of the letters. So what I mean by that is we have A, B, and C. If I want to just arrange the letters A, B, and C, I can say A, B, and C. I can say C, B, and A. I can say B, C, and A. I can keep switching them like that. So every time I'm switching them around, it's a different permutation. The order's mattering, and I'm counting like this is 1, this is 2, this is 3. It's the same letters, but the order of them is mattering, and I'm counting them different as I go. So I can say, well, for my first spot, there's 3. For my second spot, now I used up 1 letter, I'm having 2. Then for my third spot, since I only have 1 letter left, there's 1. There's going to be 6 total for this. And I'm going to show you how to do this on the calculator as well. Okay, Olympic bobsledding event. So now we're going to have 10 teams finishing in the competition. And as you might be able to see with my blanks, we can do this the same way. I can say, I can go with 10. Oops, let's do that in the blank above it. I can say 10, 9, 8, and I can go on and draw 10 blanks. But that can take a while if we had 100 teams or 1,000 teams, because I don't want to be drawing blanks and multiplying on my calculator. So if we're just doing 10 times 9 times 8 times 7 times 6 times 5 and keep going on forever, another way we could do that is 10, and then it looks like an exclamation point. That's called factorial. Same with this. This was 3 factorial. And it's the same thing as saying 10 times 9 times 8 times 7. Oops. Times 7 times 6. I'll write that out for you. times 2 times 1. And the buttons on your calculator are going to be, if you go to the math button on your calculator, and then there's an arrow key, and over to the probability, PRB. We're going to use this a lot today. And you're going to go down to number 4. It's the exclamation point. It looks like that. That's the factorial button. Now, for most calculators, you're going to have to put the 10 in first. You're going to have to put the 10 in first. And I want to make sure you can get 3,628,800 for that. So that's if all of the teams, that's how many different permutations we have of all of the teams finishing. It's a little different than the second. They want to know how many can just 3 teams finish, first, second, and third. So now we have 10 teams total, but we want to know how many 3 of them are going to finish. So we have 10 total, and we're looking for 3 of them. And this is going to be a permutation because order matters, so it's a permutation. So we're going to go on our calculator, and if you look down at the second button on that same menu, it's going to look like this. Now this is where your calculators are going to be a little different. Most of them, you're going to have to put the 10 in first, then go to math, then go over to the probability screen, then go down to option 2, which is the NPR, then put in the 3. And you should get 720. Try it and make sure you can get 720. The next problem. We're burning a demo CD for a band, and we have 27 songs on a computer, but we only want to put 5 songs, and it wants to know how many different orders we can burn the 5 songs. So we know that order matters because they're asking us how many different orders. So now we're going to have 27, and because the order matters, we're having 5 of them. So we're going to do the same thing on the calculator and try that. And I want to make sure, depending on your calculator, it might be a little different, your input. We're getting 9,687,600. The next section is going to talk about permutations with repetition. And what that means in this section, an example would be rearranging letters in words when we have more than one letter that's going to show up. It's going to repeat, so it's going to show up more than once. So if you have, let's look at Mississippi. That's our second example. We can already see we have a lot of S's, we have more than one P, we have more than one I. So that's going to affect our total number of permutations we can have because letters are going to repeat themselves. So if we look at the formula, what it's going to break it down a little bit, N is referring to the total number that we have. So in Mississippi, I'm going to look at my total number of letters. So the first thing I would do, since I started with Mississippi, I'll use that example first, is I would just count up the total number of letters I have in the word. And total letters would be 11. And so if I look at that formula, that would be my numerator. I'd have 11 factorial. And then what S refers to, this would be anything I have that's repeated. That would go in my denominator. So it's easy to get confused or to miss something, especially when you get a word like this. So I would suggest you just make a list on the side so you don't miss anything. So I would just go off to the side and write every letter you see, and I would list them all. And I would have M, you'd see once, and then I, and then you have S and P, and I would count them all up to make sure you don't miss anything. So there's 4 I's, and then S, 1, 2, 3, 4 S's, and then 2 P's. 2. And so for 1 factorial would just be a 1 in the numerator. And then in the denominator, I'm going to put everything that repeats. So I'm going to say 4 factorial times 4 factorial times 2 factorial, which is just times 2, 2 times 1. This is what I'm going to put in the calculator. Please try it, because if you're putting all of this in at once, you need to put it in parentheses. Make sure, I would pause, try this on your own on the calculator, and then you want to make sure you're coming up with 34,650. Please try the other 3 examples before you watch me do them, just to make sure you can do them on your own as well before you check your answers. For Panama, you should have 6 factorial over 3 factorial. It's 120. Tree, 4 factorial over 2 factorial. 12. And yellow, there's 6 total letters. L repeats, and it's 2 times. That's where 2's coming from. And that would come out to be 360. So there'd be 360 distinguishable permutations. And that's what these are. We're looking for the number of distinguishable permutations.